This video will cover difficult questions regarding the topic of limit by factoring. Here is the first question. When you put 27 into x, you get the 0 over 0 form. We can use substitution to solve. Always substitute the smallest term. Therefore, let x to the power of 1/3 be a. Then cube each side. Then we get x equals a cubed. X approaching 27 is the same as a approaching 3 because when you put 27 into x, we get 3. So it means a approaching 3, the same. So the limit becomes x to the power of 1/3 equals a. X means a cubed. A cubed minus 27 can be factored. A cubed minus b cubed equals a minus b, a squared plus ab plus b squared. So a cubed minus 27 means a cubed minus 3 cubed equals a minus 3 a squared plus 3a plus 3 squared, which is 9. So we can then factor the denominator into a minus 3 a squared plus 3a plus 9. Then cancel the common factor, which is a minus 3. Then put 3 into a. So 3 squared is 9. 3 times 3 is 9. Also 9, which equals 1 over 27. That is the answer. This is the next question. When you put minus 8 into x, it makes the 0 over 0 form again. It is similar to question 1. So let x to the power of 1/3 be a. Then cube each side to get x equals a cubed. When you put minus 8 into x, you get minus 2. So as x approaches minus 8, means cube root minus 8 equals cube root minus 2 cubed, which means minus 2. So that means a approaches minus 2 is the same. A approaches minus 2, x equals a cubed over a plus 2 and a cubed plus 8. Use this formula. can then factor the numerator as a plus 2a squared minus 2a plus 4 over a plus 2. Then cancel the common factor. A squared minus 2a plus 4. Then put minus 2 into a. So minus 2 squared is 4. Minus 2 times minus 2 is also 4. Then plus 4. The answer is 12. This is the next question. This question is also in the 0 over 0 form. So let x to the power of 1 over 6 be a. Then raise each side to the 6th power. Then we will get x equals a to the power of 6. Then when x approaches 1, when x equals 1, a is also 1. So a approaches 1. The limit becomes this. So this is a minus 1. Do you remember the factoring review at the beginning of the moderate limit by factoring video? The denominator can be written as a minus 1 and a to the power of 5, just one number less than 6. In descending order. Like this. And then cancel the common factor. And put 1 into a. Everything is 1. So 1 to the power of 5 is 1. So 1, 1, 1, 1, and 1. 6 of them. So answer is 1 over 6. This is the next question. It is in the 0 over 0 form. When we use substitution, which term is changed? It is the smallest term, so x to the power of 1 over 6. A. Then cube each side, so this is 3 over 6 a cubed. So finally we have this one. So x to the power of 1 over 2 equals a cubed. When you put 64 into x, this one is 2 to the power of 6. So cancel out. So finally 2 equals a. Therefore x approaching 64 is the same as a approaching 2. So the limit becomes this one is a minus 2 over a cubed minus 8. It's a minus 2 over, you can factor the denominator into a minus 2 a squared plus 2a plus 4. And cancel the common factor. and then put 2 into a, 2 squared plus 2 times 2 plus 4. So 1 over 4 plus 4 plus 4. So answer is 1 over 12. This is question 5. This is also in the 0 over 0 form. So we can factor the numerator into x minus 1 and x squared plus x plus 1 over x minus 1 and x to the power of 4, 3, 2, 1, and x to the power of 0, which means just 1. And then cancel the common factor. So it's x squared plus x plus 1, x to the power of 4 plus x cubed, x squared plus x plus 1. Then put 1 into x. This is 1 plus 1 plus 1. And this one is 1, 2, 3, 4, 5. So 1 plus 1 plus 1 plus 1 plus 1 is 5 over them. So 3 over 5. That is the answer. Here is the next question. This is complex fraction with a 0 over 0 form. To make a complex fraction into a single fraction, we need the least common multiple of the numerator and the denominator. That number is 4x. So multiply each side by 4x. The limit becomes, expand the numerator, and then don't expand the denominator as it is already in the factored form. Simplify x plus 4 over 4x, 4 plus x, and then cancel the common factor, which is x plus 4, and 1 over 4x. Then put minus 4 into x. So the answer is minus 1 over 16. The next question is this. This question shows the 0 over 0 form. There are two ways to solve this question. First, 2 minus square root of x. We can factor the denominator into x times 4 minus x. But this is not factored fully. 4 minus x is not a difference of squares. However, we can change it to become a difference of squares by creating a squared minus b squared form, which is 2 squared minus the square root of x squared. So this can then be factored into 2 minus the square root of x, 2 plus square root of x. And then rewrite the question, 2 minus the square root of x over x times 2 minus the square root of x, 2 plus the square root of x. And then cancel the common factor, 2 minus the square root of x, 1 over, then put 4 into x, so 4, 2 plus the square root of 4, so 1 over 4 times 2 plus 2, which is 4, so answer is 1 over 16. The second method to solve uses substitution. I think this technique is easier than the first one. Let the smallest term square root of x be a. Clear each side to get x equals a squared. So x equals a squared here. Therefore, when x approaches 4, that means a approaches 2. Then the limit becomes 2 minus a over 4, x means a squared, minus x squared means square each side, which is a to the power of 4. And we can factor, take out a squared, then we can factor more. So 4 minus a squared becomes 2 minus a and 2 plus a. Then cancel the common factor. Then simplify. Then put 2 into a is 1 over 2 squared and 2 plus 2. So 1 over 4 times 4, which is 1 over 16. Finally, we get the same answer. This is question 8. This question is in the 0 over 0 form. It is similar to question 6. We need the least common multiple of the numerator and the denominator to make a single fraction. It is 3 times 3 plus h for each side. Then expand the numerator, the first one, second one, over, but do not expand the denominator as it is already in the vectored form. So 3h, 3 plus h, and then 3 minus 3 plus h, simplified numerator 3 minus 3 minus h over 3h, 3 plus h, and cancel minus h over 3h, 3 plus h, then cancel the common factor h, so limit as h approaches 0 of minus 1 over 3 plus h. Then put 0 into h, minus 1 over 3 times 3 plus 0. So minus 1 over 3 times 3, which is 9. So the final answer is minus 1 over 9. This is the next question. There are two ways to solve. When x equals a, the numerator and denominator both becomes 0. So this creates the 0 over 0 form. This means that x minus a is the common factor. First, we can use synthetic division to solve. Understand that x is the variable and a is the constant. Copy the coefficient is 1 minus a squared minus a cubed. And divide by a, which arises from x minus a. So 1 down, times and add, times and add, times and add. So this a means x minus a, and then this one is 0, 1, 2. So x squared plus a squared. Therefore, the numerator can be factored into x minus a, x squared plus a squared over x minus a. Then cancel the common factor. Then put a into x, so a squared plus another a squared. So final answer is 2a squared. The second way is to solve by grouping. Group the polynomials into pairs. And then factor each pair of 2. Take out x squared and x minus a, and then a squared is common factor, and x minus a. And then take out the common factor x minus a, and then the remaining factor becomes x squared plus a squared. So the limit becomes like this, and then cancel the common factor. Now it's the same as the first technique. Like this, and the answer is 2a squared. Here is the next question. It is in the 0 over 0 form. We could factor the numerator, but that takes a lot of work. Instead, I will expand first using Pascal's triangle. Do you remember? But this one is minus, then plus, minus, like this. So a minus b cubed equals a cubed minus 3 a squared b plus 3 ab squared minus b cubed. So x minus 1 cubed equals x cubed minus 3 x squared times 1 plus 3x times 1 squared minus 1 cubed equals x cubed minus 3x squared plus 3x minus 1. So the limit becomes x cubed minus 3x squared plus 3x minus 1 plus 8 over x plus 1. Simplify the numerator is x cubed minus 3x squared plus 3x plus 7 over x plus 1. It is still in the 0 over 0 form. The numerator can now be factored more easily. We will use synthetic division. So copy the coefficient. 1 minus 3, 3, 7. And then divide by minus 1. So 1 down times, add, times, add, times, add. So that one is x plus 1, and this one is 0, 1, 2. So x squared minus 4x plus 7. So the limit becomes x plus 1, x squared minus 4x plus 7 over x plus 1. So cancel the common factor and simplify. Then put minus 1 into x. Minus 1 squared minus 4 times minus 1 plus 7. So 1 plus 4 plus 7. So you get 12 as the answer. This is question 11. It is similar to question 10. When you put 0 into t, it makes the 0 over 0 form. We will expand the numerator using Pascal's triangle. Finally 1, 4, 6, 4, 1, this one. So when a plus b to the power of 4 expanded, a to the power of 4 plus 4, a cubed b plus 6, a squared b squared plus 4, ab cubed plus b to the power of 4. So t plus 1 to the power of 4 equals t to the power of 4 plus 4 times t cubed times 1 plus 6 t squared times 1 squared plus 4 t times 1 cubed plus 1 to the power of 4, which is t to the power of 4 plus 4 t cubed plus 6 t squared plus 4t plus 1. Now the limit becomes t to the power of 4 plus 4t cubed 6t squared 4t plus 1 minus 1 over t. You can cancel the ones. Then limit as t approaches 0 of t to the power of 4 cubed 6t squared plus 4t over t. Then t is a common factor, so take out t. Then cancel these two. So t cubed plus 4t squared 6t plus 4. Then put 0 into t. So 0 cubed 4 times 0 squared, which is 0, and 6 times 0 is 0 plus 4. So the final answer is 4. This is the next question. When x approaches 1, the denominator becomes 0. As the answer of the limit is b, the numerator must also be 0 to create the 0 over 0 form. Therefore, limit as x approaches 1 of ax minus 3x squared must be 0. So put 1 into x, a minus 3 equals 0. Therefore, a equals 3. Now go back and solve for the left side. Put 3 into a. So limit x approaches 1. A is 3. So 3x minus 3x squared over x minus 1 equals limit x approaches 1. Then factor the numerator into 3x 1 minus x over x minus 1. Then limit x approaches 1. In order to cancel the common factor, you must take out the negative sign. Change the order. So limit becomes like this, and then cancel the common factor. Then simplify. Then put 1 into x. So the answer is minus 3, which equals the right side. Therefore, b equals minus 3. This is the final equation. While this question looks similar to last one, it's actually a bit more difficult. However, the first part remains the same. When x approaches 2, the denominator equals 0. Since the answer of the limit is 1, the numerator must also equal 0 to create the 0 over 0 form. For the numerator, the limit as x approaches 2, x squared plus ax plus b equals 0. So put 2 into x, the 2 squared equals 4, plus a times 2 is 2a plus b equals 0. Then solve for b. So b equals minus 2a minus 4. Now for the harder part. When there are two variables in the problem, there must be two equations, like a system. Since there is only one equation here, one of the variables must be solved for first. Look at the original equation. X is actually the variable while a and b are constant. In this case, we will solve for b, as a is the coefficient of x while b is simply a constant. So we will put b, this one, into the original numerator here, or here is the same thing. So the limit becomes x squared plus ax plus b, which is minus 2a minus 4 equals 0. Remember how it equals 0? That means the numerator must have a factor of x minus 2. There are two ways to factor. First, we can try grouping. If you don't know which ones to group, there is a rule for that. Choose the terms with a variable of lowest degree. While x has a degree of 2 and 1, a only has a degree of 1. So you have a group with A and a group without A. That is the key. And then factor, so take out A, then x minus 2 plus this one is x minus 2, x plus 2. Then common factor is x minus 2, so take out this one. And then the remaining factor A plus x plus 2. So this is factored form. The second way is using synthetic division. So this one is x squared plus ax. So actually that one is constant term. So there are only 3 terms. So coefficient is 1, a minus 2a minus 4. And then divisor is 2, because the original limit must have the common factor of x minus 2. So 1 down and times, add, times, add. So 2 means x minus 2, and that one is x plus, this is 1 term, a plus 2. So this is factored form. Now the original limit question can be rewrite x minus 2, x plus a plus 2 over x minus 2. The numerator has changed from this one, the same as this one, and here, finally, that one. Change it like this. And cancel the common factor. Simplify. X plus a plus 2. So put 2 into x. 2 plus a plus 2, which is 4 plus a. It's the same as right hand, so 1. So therefore a equals minus 3. And then finally we go back to b here. So b equals minus 2a minus 4. So minus 2 times minus 3 minus 4, 6 minus 4. So b equals 2. That is the final answer. I hope this video has been helpful. This is the last of 3 videos covering the limit by factoring. Previous lessons are linked in the description bar below. If you have any questions, please leave them in a comment. Thank you for watching. Please like and subscribe for more.